Hello friends, I welcome you all in this session. In previous session we were discussing about one of the important areas of project management, and that area is quality management, right? And we have seen that quality has got different connotations, and whatever is a quality product for you may not be quality product for me, and there are different views about quality by different experts, right? And we have seen 8 dimensions of quality, CARS, PPF, right? And we have seen 3 aspects of quality, right? Quality of design, quality of conformance, and quality of performance, right? And we have also seen what is the or what are the reasons for studying cost of quality separately. Why should not be studied with other costs? So, the reasons are mainly you have got product complexities, costs are increasing because of product complexities, and you have got lots of repairs and maintenance during usable life cycle of the project, right. So, these are 2 main reasons for which due to which you should study cost of capital, cost of quality separately, right. So, in previous session we also discussed prevention cost, right. Let us look at the second type of quality cost, and it is appraisal cost, right. Whenever you make a product, as I said, you need to take measurement at different stages, right. So, you need to measure whether things are properly moving or not, right. So, you need to measure dimensions, you need to evaluate if something has gone wrong, you need to audit the product and components, and whenever you are receiving raw materials from vendors, you need to inspect raw materials and components, right. So, all those costs related to those things are called appraisal cost, right. You are ensuring that again the product is confirming, right. So, you can say that the appraisal cost and the previous cost which we have just seen, prevention cost, these 2 are the costs related to conformity of the product, right. We do not want non-conforming products, right. Now, there are different sub costs related to appraisal cost, right. So, the first is inspection and test of incoming material. Since you are getting raw materials, sometimes semi finished materials from different vendors, and if you are a large organization, you might be having hundreds of such vendors, right. So, you need to either test those incoming materials in your organization or in your plant, or you should encourage your vendors to supply you quality products. So, you need not check in your plant, let the vendor produce quality product, right. So, you can avoid this step in your plant, right, inspection and test of incoming materials. So, you need to make your vendors capable to manufacture quality product, right. Then product inspection and test, of course, the first part was related to incoming material, right. Now, since you have started making product, so product inspection and test, you are testing it at different stages, right. So, that is cost of one of the costs of appraisal type, right. Materials and services consumed, this is very important. You see what happens many times when you test something, some incoming material, or let us say the material which is being manufactured in your organization, you need to consume some materials, right. Let us say if you are doing a non-destructive testing, so you will have to let us say if in case of let us say you are making bricks, right, bricks which you use for making buildings, right. So, to check the strength of brick, you need to crush it, right, and during that process the material would be consumed, right. It won't be useful for further use, right. So in this process you are consuming the material. Let us say if you are making, let us say DO, right, a body what is called, let us say perfume, right, you are making perfume. So you want to check quality of perfume, so you need to spray it, right. So when you spray it, it won't be there in the spray bottle, right, because you have consumed it in testing itself, right. So you need to sometimes consume materials during testing itself, right, especially in destructive testing, right. So cost of those materials is one of the appraisal costs, right. Maintaining accuracy of test equipment, very important. Let us say if you are making shafts and you are measuring diameter of shafts, right, and when you use, let us say, vernier caliper to measure diameter of the shaft, what will happen after some time, the edges of the caliper would worn out, and if you continue measuring using vernier caliper, then even you would be clearing those shafts which have got more dimension than the required one. So you need to calibrate your machines and equipment time to time. So the cost of calibration, cost of maintaining your machines and equipment updated accurately, they should measure the products, right. So costs related to those are also appraisal costs, right. Now let us look at some other costs, right. You have got internal failure cost. When I say internal failure cost, the costs which you incur in the product before you supply it to your client or before handing over the project to the client, you need to incur some, whenever you incur some cost, those are called internal failure costs, right. And these type of costs are scrap. In a project you will have several scraps, because you have got in a project you would be getting materials from hundreds of vendors, and scrap is that material from which you cannot recover any money, right. So let us say if you are making a shaft, once again I will take the same example, and the diameter is, let us say 3 centimeter, right, and the shaft which has come out of the process is just say, let us say 2.5 centimeter. Now it is a waste, right. You cannot economically recover any money, right, from it. But if the diameter of the shaft is, let us say 3.25 centimeters, so you can rework on it, right. So that is so if you are able to rework it, it is fine, otherwise it is a scrap, right. So the cost which you cannot economically recover, right, is scrap. Then you have got rework. I just gave you an example. If the diameter of the shaft is 3.25 centimeter, then you need to rework it, right, and for that you need to incur cost, you need to incur machine cost, you need to incur labor cost, right. Failure analysis, this is good one, right. Whenever something goes wrong, you need to find out what are the causes of that failure, and you need to do something called cause and effect analysis, and there is something called failure mode effect analysis, right. So you need to find out the reasons for failures, whether the reasons are due to the mistake of the worker, or or there is some problem with the machine, or there is some problem with the raw material, or there is some problem with the manufacturing method, or some other problem, right. So, you need to identify the cause of the failure, right. So, those costs come under internal failure cost, right. Then you have got downtime cost. Whenever there is a breakdown in assembly line, so you are not making products, that would be a loss to your organization, right. So, downtime cost. Then you have got yield losses. Yield losses, what happens, let me give you an example of a soft drink company, right. So, in a bottle you need to have a specific quantity of beverage, right, and let us say that quantity is 300 ml. If you are filling more than 300 ml, then it is a kind of yield loss due to some problem in setting of the machine, right. So, you need to focus on yield losses also, right. And finally, you have got downgrading or off spacing. Now, let us say you are making a product and its price is, let us say, X rupees, right, but there are some problems in that product. So, because of that, because of those problems, you are not able to sell in X rupees. So, you will sell it at some lower price, right, let us say X minus delta X, is not it. So, that would be the price which you would be getting for that particular product, right. So, you will have different prices for the same product. So, that is known as downgrading or off spacing, right. So, for the same product you will have different prices. So, that is also a part of internal failure cost, right. Now, apart from, and these costs will be there whether it is a manufacturing organization or a service organization, right. So, these costs will be there, right. Let us look at the fourth type of quality of cost, and this is external failure cost. It depends on what kind of product you are looking at, what kind of market you are looking at, what kind of organization you are in, right, what kind of sector you are in, right. So, look at external failure cost. Now, these are the costs which you incur once you supply the project to the client, right. So, that is why they are called external failure cost, right. So, you are getting different complaints from different customers about product. So, you need to have people in your in let us say customer complaint cell. So, you need to you are employing certain people in that customer complaint cell, and different they would be having different equipment, different complaint register system will be there, isn't it. So, all those costs related to complaint, right. Then you have got return product and material. Since the product is in, let us say, guarantee period, and there is a complaint in the product, so you need to get it back. So, there is something called return product, right. So, either you may get it from, let us say, either from dealer or from retailer or from customer sometimes, right. So, cost related to returning of products, right. Then you have got warranty charges, right. You have got warranty and guarantee claims. So, these costs also come under external failure cost, right. Nowadays, since customers are more knowledgeable, they have got several information with them, and whenever something goes wrong with the product, they are ready to go in court of law, right. So, the cost related to the litigations and so on are liability costs, right. So, you should be careful about these litigations and all those things, right. And apart from these four costs, complaint, return, warranty, liability, there is something called indirect costs. Now, these are costs which are difficult to measure, because let us say if customer is not happy, right, so he might go to some other product, right. So, it is very difficult to measure that cost, right. So, the cost related to customer dissatisfaction, right, it is very difficult to calculate, right. So, these are couple of let us say the customer is not happy with the brand now. So, how to measure that cost, isn't it? So, these are couple of indirect costs. So, all these are external failure costs. So, we have seen 4 types of costs: prevention cost, appraisal cost, internal failure and external failure, right. So, we can say that the internal and external failures are the cost related to cost related to non-conforming items, right. So, we want to convert those non-conforming items to conforming items, right, while prevention and appraisal cost are to ensure that we make conforming products, right. So, these are different cost of curves, and we have got let me draw these curves on board. So, you have got let us say on x axis you have got the quality. So, let us say you have got 100% quality product here, let us say 100% defective product here, right. So, 100% defective product here, and you have got 100% correct product, right, or 100% non-defective product, right, non-defective. So, you have got these costs. This is cost curve, it is called internal and external failure. Internal and external failures, right. So, this cost is more if product is defective, right, or non-conforming, right. If product is non-defective, then you will have less of this internal and external failures. On the other hand, you have got prevention and appraisal cost, right. Since you want 100% 100% non-defective part or non-conforming item, you need to incur more and more, right, isn't it? So, this is the relationship between these two curves, and there would be a total cost curve, right. So, this would be like this, just a minute. So, this is this, right, and the third one, which is a total cost curve, is like this. So, this total cost curve is symbol of right, isn't it, right symbol, right. So, this is the form of total cost curve, right, okay, and this is your optimum cost, right. So, your product should have this much of quality into it, right. If you infuse more quality, then total cost will increase, right. Okay. So, this is optimum quality level, right. Now, we have seen one of the definitions as that quality is inversely proportional to variability, and variability is what? It is basically dispersion, right. When you have got let us say if you are making a pen of 6 inches height, and if you are making pens having different heights, then it is called variability, right. And if you look at this variability in this particular figure, so there are 3 curves, right, or 3 distributions. So, you have got distribution A, this is your second distribution, right, this is B, and this is third distribution C. So, which has got more variability here? More variability or more dispersion is in curve C, right, isn't it? Similarly, for if you look at curve A, least dispersion, and the variability is measured in terms of there are various methods of measuring variability. The first is range. A range is the difference between maximum to minimum value, right. So, let us say if you are making 100 pens of size, let us say 6 inches, right, and the maximum height of a pen is let us say 6.25 centimeter and minimum is let us say 5.9. So, the difference is the difference between these two numbers will give you the range, right. So, range is one of the measures of variability, right, but range is not a good measure of variability because it considers only 2 points, maximum point and minimum point. So, there is another method, it is called standard deviation, right. So, we denote it by sigma, right. So, sigma is nothing but standard deviation, and standard deviation is what? A method of measuring dispersion, right, or a measure of a method of measuring variability, right. So, let us look at this curve, very important curve. All of you would be knowing that a normal distribution curve, a bell shaped curve, it's a symmetric curve, right, and other properties of this curve are within one sigma limit, right. So, you will have 68.2% quality product. Within 2 sigma limits you will have 95.44 quality products if you are making 100 products, right. Similarly, if you are making 100 products, then 99.73 products would be confirming products or non-defective products, right, or right products, right. So, this curve will help us in knowing what is 6 sigma quality definition, right. So, let us move on to next slide. This is basically an example I wanted to share with you. This is in fact there is an American company, American automobile company, which has got a plant in US, and that plant manufactures transmission system for the automobile, and the company also gets transmission system from a plant based in a company based in Japan, right. So, the American company found that the warranty and guarantee costs were very high in case of transmissions coming from company based in US or the manufacturing plant based in US, while the warranty and guarantee claims were very low for the transmission systems made in a company based in Japan, right. So, they tried to find out the reasons for this, why there is more guarantee and warranty claims. When they analyzed this in detail, they found that it is the variability, right. The transmission systems which they were manufacturing in American plant, they were having more variability, while the Japanese plant their variability was small, right. And when they did it further analysis, they found it that the Japanese plant was using 25% of the specification band. And what is specification band? You have got lower specification limit and upper specification limit. So, this total is called 100% band, right. So, for making transmission system, the Japanese company was using only 25% of this band, while the American the plant which was there in US, it was using 75% of the total band. So, that is why they were having more variability. So, this is just an example how you can improve quality of a product by reducing variability, right. Okay. So, let us look at one more point before I finish this session. There are several sources of variability. In fact, every organization wants to produce quality product in first time. No organization wants to do rework, or they do not want to recall the product, they want to do it for the first time, but they do not do it. Why? Why they do not do it for the first time? Because of several disturbances, and disturbances are internal disturbances and external disturbances. So, let us look at a process. In a process there are several inputs, right? You will have several input variables, right? Maybe in terms of, let us say, labor input, material input, right? Let us say method input and so on, right? So, you have got certain inputs and you are processing those inputs, right, to make some final product, and final product is your output, right? So, the final product could be a product, right, or the output could be final product, it can be a service, or you can also have a waste, right, is not it? Waste can also be one of the outputs, right. So, you can have several inputs and you can have several outputs, either product as an output, service as an output, byproduct as an output, waste as an output, and the one more intangible output is learning, right. In fact, pollution is also an output, right. So, one of the intangible outputs is learning from the process, right. What went wrong, why you wanted to make something but you could not make it. So, there would be learnings also, right. And then there are certain controllable factors. Now, those factors which you can control, right, they are under the control of management, but there are certain uncontrollable factors, and these are problematic factors, right. Because of these you do not get quality products or quality project. And let us say these uncontrollable factors are what? These uncontrollable factors are, let us say, competition is uncontrollable factor, right. So, you have got several competitors and you may have competitors coming in day by day, right. So, that you cannot control. But if you talk about a manufacturing process, then the uncontrollable factors are, let us say, temperature, pressure, humidity, inherent qualities of incoming materials, right. Since you are getting raw materials from different vendors and all the vendors will not have same quality of raw materials. So, you do not have control over these things, right, and they are uncontrollable factors, right. So, you need to control these controllable factors and try to minimize the effect of uncontrollable variable on value of y, right. So, we will see in next few classes how to design your experiment so that you minimize variability in your output. So, we do not want variability here, right. So, what we want? We want to know which are those controllable variables affecting y. This is the first thing we want to know, which is the most important controllable variable which is affecting y, right. We want to set these variables x1, x2 and x3 and xn in such that we get value of y as near optimum, right. So, determine where to set the influential variable so that y is near optimum or exactly optimum. Determine where to set all influential x so that variability is small. Determine where to set the influential x's so that variability is small, right. We want to minimize variability. In this step what we wanted? We wanted to have value of y near optimum. Here we want to minimize variability, and determine where to set the influential x so that the effect of uncontrollable variables, that is z, are minimized. So, let me give you an example. Let me compare this process with the classroom situation. So, in a classroom, let us say there are some good students and there are some naughty students, right. So, these good students are controllable variables, right, and output is at the end of the day learning is the output. So, as a teacher I want to control all my good students, right. I should control them in such a way that at the end of the day total learning of the class is more and more, but there are certain naughty students, right. So, I want to control them, naughty students. So, what should I do? I should ask a good student to accompany a naughty student, right, so that I will minimize their effect on learning process. So, these are couple of things which you should remember in this session, and in next couple of sessions we will continue to talk about quality management, and we will see what is design of experiment, what are different quality control tools and so on, right. So, with this let me finish here. Thank you very much.